Hello, welcome to ANS Solver. This is the eighth question of the paper. So we need to first convert 0 0.5 cos theta minus 1.2 sin theta into r cos theta plus alpha form. So now if you look at this form, you see that the part here is basically the cos compound angle formula. So I can write this as r into, cos theta cos alpha minus sine theta sine alpha. Okay, so I can write this basically as r cos theta. Sorry, I can write this as r cos theta cos alpha. Okay, minus r sine theta sine alpha. Now I know both of these are equal. If they are equal, I can compare both of them. What does compare mean? I have cos theta here. What is the coefficient of cos theta? R cos alpha, correct? Of cos theta, which is equal to the cos theta coefficient here, which is 0.5. So I can simply write this as cos alpha equals to 0.5 over r. Now in the same way, I have sine theta here, I have sine theta here. So I can write this as r sine alpha equals to 1.2. So I get my sine alpha basically as 1.2 over r. Now, to get logical sense to it, what I can do is I can make a simple triangle, a right angle triangle. Okay. I can make a right angled triangle. Okay. So when I do that, I can say that this angle here is alpha. If this angle is alpha, I know cos is adjacent over hypotenuse. So this is basically 0.5 with r as the hypotenuse. And sine I know is opposite over hypotenuse. So this is 1.2 with r. So now I can say r, is equal to the square root of 0.5 the whole square plus 1.2 the whole square. So now I can simply, solve this on the calci, correct? So 0.5 the whole square plus 1.2 the whole square, the square root. So I get my answer as 1.3. Now we need alpha. We know cos alpha is equal to 0.5 over r. So I can say this is simply alpha equals to cos inverse of 0.5 over 1.3. Make sure you're on the degree mode because your domain is in degrees, on the calci, and simply do cos inverse of 0.5 over 1.3. Okay, so when you solve this, you get your alpha value basically as 67.4 degrees. So now I can write this in the form as 1.3 cos theta plus 67.4 degrees, which is basically the final answer of part 1. Now part 2, hence solve this equation. We know this can be written in this form. So I can simply write this as 1.3 cos theta plus 67.4 is equal to 0.8. So now I can simply write this as cos theta plus 67.4 is equal to 0.8 over 1.3. Now I know cos needs to be positive here, correct? So if I see my ASTC curve, cos is positive in the first quadrant and in the last quadrant. So for the first quadrant, I simply do, on my calci, I simply do cos inverse, of 0.8 over 1.3. So when I do that on the calci, I get my answer as 52.02. Comma, now for the last quadrant, I do 360 minus theta. And theta is basically the value you got in the positive quadrant. So I can simply do 360 minus 52.02. So when I do that, I get my answer basically as 307.98. So now I can write theta, I can subtract 67.4 with the respective values. Okay, so when I do that, I get my answer basically as minus 15.38. Okay, and your 307.98 minus 67.4. Okay, so when I solve that on the calci, I simply get 240.6. But now see, your domain or your value from here to here has gone one quadrant. That means this has a third value, okay, which satisfies the equation and satisfies the domain, because this value here has changed the quadrant. That means if you think about it, you know, in your ASTC curve here, your full thing is a 360, 360 degrees clockwise motion, correct? That means if this is theta here, there's another value here which is 360 plus theta, correct? If you go clockwise another direction, correct? So now what I'll simply do is, I know there's another value which exists here, which I'll write with red, which is basically 360 plus theta. You know your theta is 52.02. So when you do 360 plus 52.02, you get your answer basically as 412.02. And when you subtract 67.4 from it, okay, you get your answer basically as 344.6. Got it? So you need to know this clockwise theory of trigo. It's a concept. So the theta which you get is simply 240.6 degrees, comma 344.6 degrees, which is basically the final answer of the question of part 2 basically. Yes, so this is the third part of the question. So here we need the greatest and the least possible value when theta varies. This is a really important keyword in the question. Now if you see, you can't make sense out of this question. How is it linked to part 1 and 2? But if you notice properly, your equation in part 1 or 2 was simply 0.5 cos theta minus 1.2 sin theta. Okay, the arrows which I've drawn here. Okay, and there was a minus in middle. Now let's say, okay, this needs a little bit of number skills. If I take minus 2 common, I can write this as 0.5 cos theta minus 1.2 sin theta, correct? Agreed? Which is similar as the equation in part 1, correct? Now I know this equation here can be written in this form. So I can write this as 1.3 cos theta 3 minus 2 into 1.3 cos theta plus 67.4, okay, the whole square. But now the thing is, here they are saying theta is varying. That means we only look at the r. Okay, what we basically do is, we have two situations here. We can write this as 3 minus 2 into 1.3 the whole square, and the second situation we have is 3 minus 2 into minus 1.3 the whole square. These are two situations, okay, when they say theta varies. So basically what you do in these kind of questions, you can forget this part, only care about the r. Okay, so now what I can simply do is, I can calculate this on my calci simply. Okay, when I do this, okay, I get my answer here as 0.16, and when I solve the other part, which is 3 minus 2 into minus 1.3, okay, and when I do the whole square, I get my answer as 31.36. So these are basically my two values, okay, the greatest and least possible value, okay, when theta varies.